In this video, we're going to do some review on different integration techniques. The first thing with a fraction that I would always look for, as much fun as partial fractions are, is can I use substitution? Of course, if I made u x squared plus 3x plus 2, then du would be 2x plus 3. I don't have that up here, and I don't have a multiple of it. So, no, I've got to use integration by parts. So, I could factor the bottom to be x plus 2 and x plus 1. Okay. So that means that, let me do all my partial fraction work down here. A over x plus 2 plus b over x plus 1 is equal to x minus 1 over x plus 2 times x plus 1. Well, remember, we're thinking common denominator here, meaning we're going to multiply this by x plus 1, x plus 1, this by x plus 2, x plus 2, and now they have the same denominator, so we can really just say, alright, a times x plus 1 plus b times x plus 2 is equal to x minus 1. The numerators, essentially. We're ignoring the denominators because they're the same. Now we pick some x's. Easiest ones to pick are the ones that make the parentheses 0. So let's do negative 1. So negative 1 plus 2 is 1, so we just have b equals negative 2. Easy enough. Next one, let's pick x equals negative 2. So negative 2 plus 1, so we have negative a equals negative 3. That means a is equal to 3. Okay, so here we are. B is negative 2, a is 3. I'm going to go back and write those here, 3 and negative 2. So I can rewrite my integral to be 3 over x plus 2 dx plus negative 2 over x plus 1 dx. And I'll worry about the bounds here in just a little bit. I always pull my constants out front. That leaves me with just 1 in the numerator. The antiderivative, 1 over x plus 2 would be natural log, so 3 times the natural log of x plus 2 minus 2 times the natural log of x plus 1. There's my antiderivative. Now remember, I'm evaluating this at 1 and 0. Okay, so let's think now. If I plug in 1, I've got 3 times the natural log of 3. So let's write that down, 3 natural log of 3 minus 2 natural log of 2 minus, if I plug in 0, I get 3 natural log of 2 minus 2 natural log of 1. Well, the natural log of 1 is just 0. Okay, that's just 0. And we could certainly do some rearranging here. You know, we could say, well, 3 natural log 3 minus 3 natural log 2. I'm just putting the ones with the same coefficients. Minus 2 natural log 2. Factor a 3 out. Use our log rules. The natural log of 3 over 2. You know, something like that. There's a lot of steps you can take past the end to simplify, but this is the basic, you know, ending spot. You could type that in your calculator or something. All right, this one, another fraction, and I just want to point out here, you make, you know, x squared plus 3x plus 2. If I found the derivative, it would be 2x plus 3. So this is very similar to the first one, or it looks very similar, but we can use substitution. And substitution is preferable because it is faster. If I made u 3x plus 2, and I made du 2x plus 3 dx, then I can just rewrite my integral as 1 over u du. It's going to be much easier. And it's obviously it's going to be natural log of u, and you'll plug in the point, but I did want to just talk about the new bounds. To find the bounds, remember, in your substituted integral, we just plug 1 in for x because we're transferring these to bounds. So 1 plus 3 plus 2 is 6. And plugging 3 in, 9 plus 9 plus 2 is 20. Okay, well, of course, the antiderivative is natural log of u, evaluated at 20 and 6, so you could just rewrite this as the natural log of 20 minus the natural log of 6, which you could write as the natural log of 20 divided by 6, which is the natural log of 10/3. Remember, if you're going to go back, if you say, well, I don't like to do it with u, if you plug in x squared plus 3x plus 2, then you got to go back to the original bounds. Okay, this is a non-terminating integration by parts. I know that because neither one terminates, and because because it's a product. Okay. So let's start off by making u e to the 2 theta. So du will be 2 e to the 2 theta. dv is equal to the cosine of 3 theta d theta. So v is equal to 1/3 sine of 3 theta. You really get good at doing substitution in your head when you have to do integration by parts. So we do the magic 7. I think it's a good idea with a non-terminating to rewrite, e to the kind of write everything out every time so you know when you hit the end. So there's my original equal to 1/3 e to the 2 theta sine 3 theta minus the integral. Now I can pull out both of those constants. I've got a 2 and a 1/3, so I'm just going to put 2/3 right here. Now I got e to the 2 theta sine of 3 theta d theta. Okay, so we got to do integration by parts again. U equals e to the 2 theta. Du is 2 e to the 2 theta. So dv was sine of 3 theta d theta. So v is equal to negative 1/3 cosine of 3 theta. Okay, magic 7. We go back and rewrite. So, again, I'm going to just start by rewriting the original. The 1/3 e to the 2 theta sine 3 theta doesn't change. Minus, okay, I got this 2/3. Okay, now I got my new integral. Let me put that in the brackets here. So we got negative 1/3 e to the 2 theta cosine 3 theta minus, and let me pull the constants out again. I got the 2 and a negative 1/3, so it's going to make it a positive 2/3. Let me just do that. And my integral will be e to the 2 theta cosine 3 theta d theta. So I'm back. I can't finish in the parentheses. I'm back to the original, though. You can see I do have that. Let me get rid of those brackets, kind of multiply everything in, so I know where I stand. E to the 2 theta cosine 3 theta d theta. So this stays the same. Okay, let me multiply that negative 2/3 in. So this becomes a plus 2/9 e to the 2 theta cosine 3 theta. Negative, that becomes a negative 4/9. And I'm just going to leave it as an integral. Okay. Now, I'm going to add, because I'm back to the original. The strategy is always you do your integration by parts twice, and I'm going to add this integral. Kind of running out of room here, so I'm going to make it really tiny. Add it to the other side as well. Oop, forgot my integral. Okay, so I've got one integral plus 4/9 of an integral, so it's like I've got 9/9 plus 4/9. I've got 13/9. The integral of 2 theta cosine of 3 theta d theta equals 1/3 e to the 2 theta sine 2 theta sine 3 theta plus 2/9 e to the 2 theta cosine of 3 theta. And to get the integral by itself, of course, I'm going to multiply both sides by 9/13, which I really should do, but I'm out of room, so put a plus c and we're done.